All right. Hello and welcome to another video. Let's start with a joke. Why did the healthy guy eat snails for breakfast? Because he didn't like fast food. Because he's healthy. Oh, okay. Today we're talking about uh, ordered selections and grouping. Okay, so we're going to take this idea of permutations and we're going to put a couple more restrictions on it and give you a couple more tools, three tools to be exact, to help you figure out more complex kind of questions. So let's start with this here. Your first kind of tip is going to be group things together. Okay. So when you're grouping things, the two things you need to think about is first order the groups and then order the individuals within the group. Okay, so let's take a look at this here. We've got six people, they stand in a line. Let's say a couple, they want to stand together, makes sense. And a group of three friends also stand together. And we want to find how many ways this can happen when they stand, when six people stand in a line. So here there are three distinct groups. The first group is the couple. Second group is the friends. Then third group is I'm going to call them the single. Okay, so how many different ways can we arrange the couple? Well, there's two factorial ways that we can arrange the couple. And then how many different ways can we arrange the friends here? Or we can arrange the friends in three factorial ways. And how many ways can we arrange the single guy? Well, there's only really one way that we can do that. So in other words, it's actually going to be how many different ways can we order these three? We're going to order the three groups. So there's three factorial ways that we can order the first three groups. And then I'm going to multiply by the different ways that we can rearrange within each group. So times 2 factorial for the friends, times 3 factorial for the 2 factorial for the couple and 3 factorial for the friends. And so once we rearrange these guys, that'll just be 6 times 6 times 2. So there should be 72 ways. I should probably get my calculator out, but that's what it is. So remember, first, you order the groups. So that's where this 3 factorial comes from. Right? That's ordering the three different groups. And then the times 2 times 3 factorial, that's by ordering the individuals within the groups. Okay, so that's technique number one. Technique number two. Okay, this is a very, very interesting one, a very, very helpful one. Deal with the complementary. So you're looking for if it says something like at least. Okay, if you've got something at least, there's a lot of different ways to calculate it. So the easiest way is to actually find the complement. So what we're doing here is we're finding the total number of ways to order something, and then we're subtracting the unacceptable ways to order it. So let's take a look at this one here. Let's say, for example, we've got how many ways can A, B, C, D, and E be ordered if the vowels must be separated? Okay, now this one here doesn't say at least, but it's like they must be separated. So in other words, it's going to be, I'll write it here, it's going to be the total, unrestricted, it's going to be take away, and I'm going to take away all the options where the vowels are together. Vowels together. Okay. So in other words, how many different ways can we order A, B, C, D, E? Well, it's going to be 5 factorial. And how many different ways can we order it if the vowels are together? So let's group A and E together. So in other words, it'll just be 4 factorial times 2 factorial, right? Because I'm just grouping. So if A and E were one clump, I'm grouping A and E together so they're together. And then I'm going to multiply it by 2 because there's in that group, there's 2 different ways that can happen. So it's going to be the total, which is 5 factorial, take away the amount of ways that I can rearrange it if the vowels were together, which is 4 factorial times 2 factorial. And let's see if I can figure this out in my head. 5 times 4, 20, 60, 5 times 4 times 3 times 2 times 1. 120. Take away 4 times 3 times 2. 24 times 2. 120 take away 48. That should be 72 ways. Okay, if I've done the math right, that should be it. If I haven't, then whoops. Okay, so that's what you do with complementary. Find the total number of ways, find the unacceptable ways, and then subtract them from one another. Okay, there's a nice technique. All right, last one. This is probably going to be the most work here. Using cases. Now, what do I mean? Normally, to make questions more difficult, they'll give you a whole bunch of different scenarios. So I'll read the question first so you can see what I mean. So they'll say, how many whole numbers are less than how many whole numbers less than 100 are odd and greater than 20, or multiples of 5 and less than 50? Okay, so with a question like this, with a lot going on, your best bet is to kind of calculate each one separately. So find how many there are less than 100 that are greater than 20, that are odd, and then the separate one would be the multiples of 5 and less than 50. So important thing here is to make sure that you subtract any overlaps. And so we're going to do that here. Let's find case number 1. So it's numbers less than 100, odd, greater than 20. Okay. So how many numbers are less than 100, odd, and greater than 20? Well, there's 80 numbers that are greater than 20, less than 100, and 40 of those are going to be odd. So there's 40 of those that are odd. Okay, case number 2, what we want is multiples of 5 less than 50. So in other words, here, there's 5, 10, 15, 20, 25, 30, 35, 40, 45. There's actually 9 of those. 50 doesn't count because 50 is not less than 50. It's the same. Now, how many of these overlap? So it needs to be greater than 20. So technically, the overlap is going to be 25, 35, and 45. So there's 3 that overlap. So both 25, all 3, 25, 35, and 45 are all numbers greater than 20. They're odds, and they're multiple of 5s less than 50. So in other words, how many whole numbers are less, how many whole numbers less than 100 that are odd and greater than 20, or multiples of 5 and less than 50? Well, there's going to be 40 plus 9, take away the overlap, which is 3. So there should just be 46 numbers. Okay, hopefully that helps. Hopefully that was nice and short and sweet. I'll see you in the next video. Catch you later. Bye-bye. Oh, happy mathing as well. Like and subscribe. See you later.